Hello everyone. So I want to go over this problem, and in this problem we are testing for a single proportion. We weren't able to cover problems like this in the homework, in class. So I want to go over it real quick. Now, a hospital reported that the normal death rate for patients with extensive burns, which is more than 40% of skin area, has been significantly reduced by the use of new fluid plasma compressors. Before the new treatment, the mortality rate for extensive burn patients was about 60%. Now, remember, as we said in class, this 60% is a population parameter, right? So it is your P, and that you're going to use for your hypothesis, HO and then H1. Using the new compressors, the hospital found that only 43 of 91 patients with extensive burns died. Now, this 43 of 91, you would use this to set up an estimated proportion or a sample proportion, right? So 43 divided by 91, that gives you your sample proportion. All right. Use a 1% level of significance to test the claim that the mortality rate has dropped. So you want to test the claim that the mortality rate has dropped, which means it is going down. So that is going to be a less than problem. So first of all, we know we are testing for a single proportion. So that one, we're going to choose that, which is done. What is the level of significance? Which is 1%, 0.01. And that we got that. And then we're going to go to the hypothesis, which is going to be, let me write that out here. So P equals 0.6, and this is for the null hypothesis. Let me rewrite it in a nicer way. So HO, which is our null hypothesis, is going to be P equals 0.6. And then our H1 or HA is P is less than, because it's going to drop, 0.6. Okay. All right. So we set up our hypothesis. Now, C says, what sampling distribution are we going to be using? So for that one, we did something like this in class. So we are going to say we're going to use the standard normal. We're going to use the standard normal. And let's see, this one, we'll assume that binomial experiment is an appropriate distribution in the sample size. Yep. So we're going to use this one because the sample size is significantly large, because we've got a 91. So we're going to use that one. So we can use the normal distribution. Oops. All right. Now, let's go to the calculation part. Okay, I'm going to erase everything from here. Okay. All right. So, it's all right. There we go. What is the value of the standardized sample test statistic? So here we are supposed to find the test statistic. Now, if you remember, we know that to find the test statistic, we are really dealing with these three formulas. Now, the first one you should be used to by now. This is Z statistic, the test statistics for the mean. And that's the formula. This is the test statistic for the proportion. And this is the test statistic, the T statistic, the T test statistic for the mean. That is when we don't have the population standard deviation. So when we don't have the population standard deviation, we're going to be given the sample standard deviation, which is the S. So the difference between the test statistics for the mean, the Z test statistics for the mean is going to be that the only difference is that this got the population standard deviation, that got the sample standard deviation, and that's it. So we're going to use, this is for proportion, and proportion you're dealing with Z statistic. So we're going to use that one. So we're going to go back to our problem. And then we are going to use the formula Z equals, or our test statistic equals P hat, P hat, oh, what's going on with my thing? P hat, that's the estimated P, minus P, and it's the same formula, what I just showed you, minus P, and P is 60%. Oops, why is this not right? Okay, minus P over PQ over N. Now, my P hat, I'm going to get that from my problem. The P hat is going to be that 43 of 91. So 43 over 91. So put that in the calculator. Let's see what you get. Now, you don't want to do a short rounding, so you should probably do to 4 decimal places. 4 decimal places or 5 decimal places. So I'm going to have Z equals, my P hat is 43 over 91 minus, my P is 0.6. That is what I use for my hypothesis, the null, and then the alternate. And then at the bottom, I have a square root. Now, everything here is under the square root. So my P is 0.6 times, now Q is 1 minus P. 1 minus P. Q is 1 minus P. So if P is 0.6, Q is 1 minus 0.6. 1 minus 0.6, which is 0.4. So P plus Q should give you 1. So my Q is 0.4. So I'm going to do times 0.4 divided by my N is 91. So 0.6 times 0.4 divided by 91. And everything there is under the square root sign. So to put this in your calculator, remember the calculator we're using on the exam. So try it with your phone calculators. Start from the bottom, okay? Start from the bottom. So 0.6 times 0.4 divided by 91. Whatever you get, put a square root on it. Put a square root on it. And then write the answer down. And then do the top. 43 divided by 91 minus 0.6. Whatever you get, divide that by what you got from the bottom. All right. And then when you do that, you should get, let me do that here. So I have I'm trying to get a calculator here. 0.6. Oops. All right, let me share this calculator. Okay. My calculator doesn't want to come up. So let me try it again this way. So you should be able to use the calculator to get your answers. All right, there we go. So I had 0.6 times 0.4 equals divided by 91 equals. So now I have this, but I have a square root which covers all of it, right? A square root. And that's my square root sign. So I put the square root on it. That's this one. And then that gives me 0.05135. So 5136. So I'm going to keep that 0.05136. So my bottom part, remember you could pause this video or go back. So I have 43 over 91 minus 0.6 over, now what I got here is 0.05136, like that. So now I'm going to concentrate on the top. I'm going to concentrate on the top. So if I go to the top, I have 43 divided by 91 equals, yep, minus 0.6. Okay, so I have a negative 0.1274722. Then it keeps going. Now I'm going to divide this by what I have at the bottom, which is 0.05136. So I'm going to do divided by, because that's what I got for the top, 0.05136 equals negative 2.48. Negative 2.48. So my Z test statistic is going to be negative 2.48. Negative 2.48. And that's going to be my answer right here. Negative 2.58. Negative 2.48, sorry. And now I find my p-value. Now remember, to find your p-value, you have to know what is going on. So this is left-tailed. It's left-tailed. So negative 2.48. And then I find the area from my table. So if I go to my table and then find the area there, I'm going to have, what is that going to be? Where's my table? Now remember, this is left-tailed, so I don't have to subtract. If it's right-tailed, then I have to do a subtraction. But here, I'm not going to do any subtraction. So I'm going to my table, share my screen again, so that you would follow what is going on. So negative, where is it? Negative 2.48. So negative 2.4 is here, and then my 8 is going to be there. So 0.0066, 0.0066, 0.0066. This becomes my p value, 0.0066 or 0.0066. So I go back and then put my answer there, 0.0066. So 0.066, that's what I have. So I'm going to put that in here for my p-value. And then now it says sketch the sampling distribution. Now this is left-tailed, so you should see that, oh yes, it's going to be this one right there. And remember, it's negative 2.48, so this seems like the right one, because it's kind of like in the middle of -3 and -2, and then it goes to the left too. So the area is shaded in blue, right? The area is blue, and that's what I wanted to get. So I think that's it. That's what I needed. Now, after choosing your curve left-tailed, remember this is left-tailed. Now it says that based on your answer, are you going to reject the null hypothesis or fail to reject? Now, look at the p-value and look at the alpha value. Alpha value is 0.01. Now, the p-value, clearly, you see that the p-value is less than the alpha. If p-value is less than the alpha, we reject the null hypothesis. The p-value is less than alpha, reject the null hypothesis. And that's it. If the p-value is greater than alpha, you fail to reject the null hypothesis. So here we are going to reject. So where is it? Yep. So at an alpha level of 0.0, where is it? 0.01, we reject the null hypothesis and conclude that the data is statistically significant. And then we come to F. Because we are rejecting the null hypothesis, then we are saying that there is sufficient evidence that at 0.01 level to conclude that the mortality rate has dropped. There is sufficient evidence because we rejected the null hypothesis. And that's it. All right. So keep on practicing. I'll see you. Bye. Bye.